Slope and rules. How can we use slope with an equation? Well, let's think about the rules that we've written so far. When we've taken a look at a couple of lines here, and each of these lines, one is the red and the blue, represented by these two equations up here, and you'll see one without any numbers in it written down below. This is called the slope-intercept form of an equation. Okay, and what we can do is we can identify certain parts of it. We know the x and the y represent the ordered pairs that we find on the line. We know that m represents the slope, and we also know that the b is representative of the y-intercept, and that is where the line crosses the y-axis. Now, we can take information, and we're going to look at writing a rule based on information first, and then we're going to go the other direction. So when we first take a look at here in example number 1, even though this says m equals 3 and b equals -2, it's really telling us that the slope is 3 and the y-intercept is -2. We can take that information and write ourselves an equation. The output, or the y, equals, we know that the slope is always with the independent variable, or the x, and that the y-intercept we would just attach on the outside there. So our equation or our rule would be y equals 3x minus 2. We do it again here. This time we have a slope of 3 and an y-intercept of 0. So at first time, when some people would go to write this rule, they might write y equals 3x plus 0. Well, do we really need to write plus 0? Because if we add 0 to anything, we know that that doesn't really change anything. So we can kind of leave our equation then at y equals 3x. And if we don't see anything out here, we know that that means that the line is going to cross the y-axis at 0, or the origin. Here we look at slope equals 1/2, and that the y-intercept equals 2. Again, a lot of people would just sit and take that 1/2, set it next to the x, and a positive 2 for the y-intercept. Now there's another way to write this 1/2 x, and we know that it's 1/2 times x, and if we put the x over 1, as we know about fractions, we need to reduce them. 1 times x is x, 2 times 1 is 2. So we get x divided by 2. So we can take a look at this, x divided by 2 plus 2, and that would give us exactly the same thing as well. So either of these would be correct. Let's take a look at another one where the slope is -5 and the y-intercept is 2/3. Again, we would write the rule y equals -5x plus 2/3. Very straightforward. Now let's kind of do it a little backwards, but before we do that, let's do a comparison. We have y equals 2x plus 3, and the way that we have learned up to this point how to graph it is we would look at the x, what we call the input, and we would input values into the equation or the rule, and we'd get an output. So let's do that. Let's put a 0 in. 2 times 0 is 0. 0 plus 3 is 3. Let's input a 1. 2 times 1 is 2. 2 plus 3 is 5. And we'll do it again with 2. 2 times 2 is 4. 4 plus 3 is 7. And we can take those points, 0, 3, 1, 5, 2, 7, and we could draw a line. I'm not going to draw a line just yet, but that's the kind of things that we would do. Now, what would happen? Some things that could go wrong. We could do wrong calculations, get wrong numbers. We could plot things in the wrong place. There's a lot of things that can go wrong. So we can instead use our newfound knowledge about slope and y-intercept and take a look at this rule, y equals 2x plus 3, and write down a couple pieces of information instead. We know when we see this that the number that is with the independent variable, as we stated earlier, is always the slope. Slope is a number, and slope specifically, the type of number it is always a fraction. So it's going to be put over 1. So we have 2 over 1, which represents the rise over run. Then we have the y-intercept when we look at this equation, and it tells us the y-intercept is 3. Of these two things, the slope and the y-intercept is the only one that is a point that is a location. It's located at 0, 3, right there, kind of where we were previously. Now, that's where we're going to begin our graph, and how we move from there is we're going to rise 2 and run 1. So rise positive 2 and run 1. And look, we ended up right on top of where we were before. And then we would draw a line. I'm going to be hopeful that my line that I draw right now is going to look straight. One never knows. There we go. Okay. So there's our line, and so these would represent all the ordered pairs. And as you can see, it's way faster to be able to make an equation when you just can get the information from it, get the slope, get the y-intercept, put that y-intercept on the graph because it is a point, and from there show the movement of the slope, positive 2 over positive 1, rise over run. Okay, let's try it a couple times. Let's take a look at this one here. Y equals 2x plus 5. We find out the slope is 2, and we know that slope is always a number and it's always a fraction. So we're going to put that over 1, and then the y-intercept is going to be positive 5. So if we go over to our graph, we know of the 2, the y-intercept is an actual point, so we're going to put it at 5, and from there, how we're going to move, positive 2, positive 1. Once we do that, so rise of positive 2, and a run of 5. Well, what we're going to do from there is that we're going to then draw our line. Here we go. It's going to let me draw my line through that, those points, and show everything that we can as ordered pairs instead of doing all that work we did before. Let's try it one more time. Y equals negative 3x plus 4. We know the slope to be negative 3 and the y-intercept to be positive 4. So we're going to take this negative 3. We know it's to be a fraction, rise over run. We're going to begin at 4, which is the location on the y-axis or the y-intercept. So we'll put a dot there. And from there, we're going to move down 3 and to the right 1, positive 1. And we're going to draw ourselves a line. Line here. Put us right through it, just like that. Okay, so you can see using slope-intercept form, it's a lot easier to do some graphing and being able to get it on the graph a little more effectively without as much error.